In the previous videos, we talked about how the most natural way and best way to measure angles is using radians. But unfortunately, there is an ancient method of measuring angles that is also still around. The ancient Mesopotamians, Babylonians, were really the first to develop what we would probably call civilization, cities, uh, agriculture, um, uh, laws, and so forth, central government. And they were among the first to develop some sophisticated mathematics, mainly for problem solving. But they were also the first culture to develop a numeration system making use of a place value system, similar to the one we use today. Their system was a sexagesimal system, in other words, using a base 60. So here's an optional thing for my geometry class. Go to my history of mathematics course and look for week one video about Babylonian numerals and see how they use them and how they work, and you can see how they were represented using base 60 using Babylonian cuneiform. Sexagesimal system persisted long past the ancient Babylonians culture. The sexagesimal systems were particularly used in trigonometry and astronomy, which were, by the way, considered basically one and the same for many centuries. And they persisted even after other systems were used in other areas of mathematics. And there's several vestiges of this ancient system that are still in use today. For example, when measuring time, there's 60 seconds in 1 minute and 60 minutes in 1 hour. That goes straight back to those ancient Babylonians. Similarly, there's an ancient angle measurement where we start with a straight angle and divide that measure into 180 equal sized increments called degrees. So 1 degree is the same as 180 degrees is the same as pi radians. So 1 degree then can be defined to be pi over 180 radians. So 180 degrees over pi equals pi over 180 degrees equals 1. And those last two fractions there can be used to convert back and forth between radians and degrees by simply multiplying the radian measure by 180 degrees over pi to convert to degree measure, cancel and then multiply the degree measure by pi over 180 degrees, cancel the degree symbol out, which is a measurement unit, and convert to degrees. Remember, radians is a unitless measure. So here's a protractor in degrees. We talked last video about a protractor in radians. So after the introduction of base 10 Hindu-Arabic numeration system, which is our modern system, degree measures were often given in decimal form, like 47.327 degrees, and that's still used. But often the Babylonians would use a sexagesimal system, and that's also still in use for finer measurements. For example, 1 degree equals 60 minutes, and 1 minute equals 60 seconds. The symbol for degree is this raised circle. For minute, it's a apostrophe or a prime. And for seconds, it's the double apostrophe, double prime, or quote mark. So 1 degree equals 60 minutes, 1 minute equals 60 seconds. And for example, here is an angle that measures 18 degrees, 12 minutes, and 30 seconds. And here you can see the steps worked out for converting it to decimal degrees. For example, just that means 18 degrees plus 12 minutes plus 30 seconds. The 12 minutes we multiply by 1 degree over 60 minutes, the minutes cancel, that makes degrees. 30 seconds is then multiplied by 1 minute over 60 seconds and then by 1 degree over 60 seconds. Each of these things, these fractions here in these darker parentheses are equal to 1. Notice the minutes, the seconds and the minutes cancel, left with degrees. The minutes cancel here, left with degrees. That's degrees. Add those together, you get 18.20833 degrees, at least approximately. Actually, I think that's exact in this particular case. We can take a degree measure multiplied by pi over 180 degrees. The degrees cancel, and we have a unitless measure, which is radians. And so this measure at the bottom is the radian measure of the angle. Here's an example where we start with decimal degrees. We take that 60.215 degrees. That's 60 degrees plus the 0.215 degrees. Take the 0.215 degrees, multiply by 60 minutes to over 1 degree. Degrees cancel, and you're in minutes, so that's 60 degrees plus 12.9 minutes. So split off the whole number part, that's 60 degrees plus 12 minutes plus the 0.9 minutes. Take the 0.9 minutes and multiply by 60 seconds over 1 minute. That works out to be 54 seconds. Then we suppress the pluses, so it's 60 degrees, 12 minutes, and 54 seconds. Or we can just take the decimal version, multiply by pi over 180 to convert to radians. If we're the one I didn't show you here is what if we started with radians and you wanted to go to degrees, it's you would take the multiply by 180 degrees over pi times this would convert back to decimal degrees, and then we already talked about how to change that to degrees, minutes, and seconds. So at this point, I would like you to go to these two videos here, converting units of angle measure, using some old stuff that I did in Geometry Sketchpad for my trigonometry class years ago. Look at that, and then this one is for adding and subtracting degrees, minutes, and seconds there. Remember that if a uh, uh, angle is indicated without a unit, it's assumed to be radians, and that again is our preferred thing. 180 degrees is nowhere near 180, it's close to 3. It's pi, which is close to 3. Finally, if you're using a protractor, in all cases, you're going to line the vertex up with some marking here where this is the origin, and then line up one ray with the 0 here and read off the scale on the other one. And here's a little video that I found somebody else did for measuring angles with a protractor.